Welcome back. Thank you for joining me to begin 11.2. Starting in this section, we are going to discuss how to multiply rational expressions. Again, what I mean by rational expressions is two polynomials being divided. Now, before we jump into the new material, I'm going to take a moment to review two of the concepts that we've been working on. First of all, factoring. This is something, again, we've done for almost 2 chapters already. So let's review factoring. When we have a quadratic trinomial, we're going to factor by making our two parentheses. I look at that 2x squared and I try to picture where did that 2x squared come from? It came from 2x and x. I look at this 12 and I ask myself, where does 12 come from? Well, 12 has some possibilities here. 1 and 12, 2 and 6, 3 and 4. But then also note that negative there. Recall that negative means when we choose these numbers, one of the numbers in our pair is going to be negative. Okay? Now, looking at this, let's use some number sense to find a good starting point. I've referenced before, when you're looking for an odd number inside there, you're never going to use two even factors. Okay? And looking at the fact we're looking for 5x, I think the 12 right there is probably a little bit big. So using number sense, I'm going to start with my 3 and 4. Okay? So I'm going to start by plugging those in, seeing what I can make happen. So 3 and 4, well, I look at my connections. This gives me 3x. That gives me 8x. So making one of those negative, can I get a positive 5x? I sure can. If I make the 3x negative, so that would mean a negative there, a positive there. If I do that, I get what I need. I get the 2x squared plus 5x minus 12. All right, looking at number 2. Here we're jumping into simplifying and finding an excluded value. So again, when we're looking to simplify this, first thing I'm going to do is I'm going to simplify the denominator. So I need to factor that quadratic trinomial. So we're going to have our two parentheses. That x squared comes from x and x. That 9 comes from 1 and 9 or 3 and 3. Looking at the fact we need 6x is going to come from 3 and 3. Now, I'm going to pause there because remember, when we're looking for excluded values, we need that denominator, all right? So this is actually very useful to us because we need to take that denominator, that x plus 3, we're going to take that and say that we cannot allow it to be 0. Okay? So we already factored it. So now we're ready for the zero product property. So I say x plus 3 can't be 0. Well, and I'm getting the same thing on the other side too. I get x plus 3 twice. Okay? Oh, I'm sorry. I keep miswriting that. X plus 3 can't be 0. So twice, you end up saying x can't be negative 3, all right? Sometimes that'll happen. If you get the same parenthesis twice, you're only going to get one thing that x can't equal. So the excluded value, you only have to write it once though. Your excluded value is that you can't let x be negative 3, all right? Now to finish the simplifying piece, I look at the numerator. I'm going to factor out a 2. So I pull out a 2 from that. I'm left with x plus 3. And now, after you factor top and bottom, we're going to cancel off whatever is the same. So my simplified version looks like this. That is my simplified rational expression. That is my excluded value. So that's what it takes to get a full answer. Excluded value and simplified form. Now let's jump into the new material. So like I said, we're going to be talking about multiplying these things. Now, when multiplying, first we're going to take a look at normal fractions. What do we do when we just had numbers? So recall how we multiplied non-algebraic expressions. So here we have 2 over 15 and 5 over 8. So something I want you to notice, okay? Notice the 2 and the 8. 2/8. We know how to reduce that, okay? So what I'm going to do is I'm going to reduce that right away. Both 2 and 8 can have 2 divided out of them. So right away, I'm going to reduce that to 1 over 4. Next, I notice 5 and 15. Both have a factor of 5. So what am I going to do? Well, I'm going to divide both by 5 to reduce that piece to 1 and 3. So even if they're in separate fractions, when they're being multiplied, if you have common factors, if you can reduce across that multiplication symbol. So here what we're left with is 1 over 3 times 1 over 4. Then again, in the end, you multiply across the top, multiply across the bottom, and you're left with 1 over 12. And the cool thing is, this same process works for these rational expressions. So, let's look at this. 2x over 3 and 12 over x squared. The first thing that I'm going to notice, this 12 and that 3. Those reduce. So to make it easier on yourself, I'm going to reduce those right away. Both are divisible by 3. So I'm going to divide both by 3. I'm going to take the 3 out of both of them right away. So what ends up happening, well here I have 2x over 1. Then over here I have 4 over x times x. Now I'd like to see, all right, does anything else cancel? Well, I can cancel off an x on top with an x on the bottom, but that's all that really cancels here. So again, now all I'm looking for is multiplying across the top. Well, across the top I have 2 times 4, or 8. The multiplying across the bottom, 1 times x, just leaves me with x. So 8 over x is our final answer for that one. All right. Looking at our next example, example 2. First thing I'm going to notice, this 3 and that 6. All right, 3 over 6. Both can be divisible by 3, so I'm going to reduce those right away. It reduces to 1/2. Okay, so right away I'm taking care of those extra numbers. And what do I do now? Well, I'm going to start canceling. So p plus 1 on top and p plus 1 on the bottom end up canceling out. P minus 2 on top, p minus 2 on the bottom end up canceling. So here, what do we end up with? Well, here we end up with 1 over 2 for the first fraction. Second fraction, remember if there's nothing left there, it's a 1. So we have 1 over 2 again. So really we're just left with 1 over 4. Again, you multiply across the top and multiply across the bottom. And that's going to end up being our final answer. Now, moving right along. Again, the goal here is to cancel anything that is the same top and bottom. So looking at number 3, n plus 4, n plus 4. Here I see n minus 3, n minus 3. Now, that 7n squared. Remember, 7n squared is the same as 7 times n times n. All right, so if we think of it as 7 times n, notice what else happens. One of those n's, oops, I apologize, the screen moved. One of those n's cancels with that n on the bottom. So again, we're always looking to cancel anything that is the same on the top and the bottom. And now let's write out what we have left. So on the top, I see a 7n. What's left on the bottom? Well, I see n plus 8 and n plus 6 left on the bottom. And that is going to be our simplified rational expression. Now, number 4. Number 4 starts getting a little bit more complicated because before we can end up canceling, remember, if it's not in factored form, we need to get it into factored form. So what I mean by that is, for number 4, the first thing we're going to do is rewrite these. So I'm going to start here first. The 24n cubed minus 64n cubed. So the first thing we have to do is figure out how are we going to factor this. So 24n cubed minus 64n squared. Well, this is not a cubic trinomial. So what I mean by that is, if you notice, we're dealing with two terms. And notice the variable is in both of those terms. So what I'm going to do is I'm going to pull out a greatest common factor between them. So looking at that, 24n cubed minus 64n cubed. Well, 24 and 64 are both divisible by 8. Then n cubed and n squared. Remember, you pull out the lower exponent that you see. So we're talking about pulling out an n squared. So once we do that, well, 24 divided by 8 gives me 3. N cubed, I'm pulling out n squared. I just have an n left. 64 dividing by 8 leaves me with 8. And then n squared, and I'm pulling out n squared. There aren't any left. So that factors that. Now, let's change gears to the top. 9n minus 24. So again, our goal is to factor, but it's not a quadratic trinomial. So what I'm going to look for is I'm going to look for a greatest common factor to pull out. What divides both 9 and 24? Well, 3 divides both 9 and 24. When I pull 3 out, 3n minus, or 9n minus, divided by 3 leaves me 3n. 24 divided by 3 leaves me 8. So after factoring this, we are left with that. So let's see how this simplifies. I can start canceling anything that is the same top and bottom. So here, 3n minus 8 is the same top and bottom. 7n is the same top and bottom. So what am I left with? Well, on the top, all I see left is a 3. Then on the bottom, all I see left is an 8n squared. So that is going to be our reduced rational expression. So moving right along, keeping our practice going. Number 5, again, you cannot cancel with those pluses or minuses. When you see all those pluses and minuses in there, your goal should be to recognize that you can factor first. If you can, you always have to factor first. So let's take a look at this. I'm going to focus on the 9r cubed minus 54r squared first. So again, only two terms, and my variable is in both of them. So to simplify this, I'm going to start by recognizing that both 9 and 54 are divisible by 9. So I'm going to pull a 9 out of there. But then, not only that, but also recognize r cubed, r squared. You can pull an r squared out of those. Remember, you can pull out the lesser of the variable that you see. So when you do that, when you pull that out, 9r cubed, and you're dividing out 9r squared. 9 divided by 9 gives you just 1. R cubed, taking away an r squared, just leaves you with an r. 54 dividing by 9 leaves you with a negative 6. And then the r squared, and you're factoring out an r squared, so it's gone. All right, so done with that one. Now I'm moving on to the denominator. So I'm going to focus right there. 9r squared plus 45r squared. Well, again, both of those are divisible by 9. And I have an r squared and an r. So that means I'm also able to pull out an r from both of those. Remember, the lesser of the exponents can be pulled out. 9r squared, I'm pulling out 9r. That's just going to leave me with an r again. 9 divided by 9 is just 1. R squared dividing out r leaves me with r. 45, and I'm dividing 9 out, leaves me with 5. Now there's an r there, but I'm dividing the r out, so I'm not left with any r. Next piece. So I'm going to move over here now. 9r squared plus 9r. So again, notice 9 and 9. Well, I can factor 9 out of that. And then r squared and r, between those, I can pull out the lesser of the exponents, which is going to be just r. So 9r squared, and I'm pulling out 9r. Well, again, that's going to leave us r. 9r, and I'm pulling out the 9r. So there I'm pulling out everything, so I'm just left with a plus 1. And then finally, our last piece of this. 9r cubed minus 54r squared. All right, so I can pull a 9 out. And then between the r squared and the r cubed, remember, we can pull out the lesser of the exponents, so r squared. 9r cubed, and I'm dividing out 9r squared. Well, that's just going to leave me with an r. 54, and I'm dividing 9 out. It's going to leave me with 6. R squared, and I'm pulling out that full r squared. So I left with that. All right, so this one, factoring, was kind of beastly. So now that we're done with all that factoring, let's take a look at what can cancel. Well, here, 9r squared, 9r squared, r minus 6, r minus 6, 9r, and 9r. So looking at all the stuff that cancels, all of this boils down to an r plus 1 on top and an r plus 5 on the bottom is all that we end up having left. All right, last problem. So looking at this, I'm going to start by factoring the top. So 6n plus 6. I notice a 6 can be pulled out of both of those. So when I take 6n plus 6, I'm dividing 6 out of that. I'm left with n plus 1. All right, now, that n plus 9 on the bottom there, that really can't be factored, okay? So that we actually get to just leave alone. So instead, I'm going to come over here. So the top of the second fraction is a quadratic trinomial. So that means we should be making our parentheses. So let's factor this out really quickly. So that n squared comes from n and n. Negative 27. Well, that can come from 1 and 27, 3 and 9. But remember, one of those has to be negative. So what combination are we looking for? Well, if I have a positive 9 with a negative 3, that'll give me the positive 6 in the middle that I'm looking for. And then on the bottom here, 6n plus 6. Well, we've actually already factored that. We've noticed we can pull the 6 out. Then we're left with n plus 1. So when I look at how to cancel these, well, 6 times n plus 1, 6 times n plus 1, n plus 9, n plus 9. So if I notice, the only thing I'm left with on top is that n minus 3. And on the bottom, everything canceled. So when everything cancels, on either the top or the bottom, all you have to put is a 1 there. So all of that boils down to n minus 3. All right, now, in terms of what are the excluded values? So, very important question, excluded values. So you know we take the denominators, and then we look to see what would make it divide by 0. Now, the important thing here is we've always gone back and worked with the original denominator, okay? So even if something cancels off, it still counts towards the excluded values here. So that means I do have to consider the n plus 9. I have to say that I can't let that equal 0. And even though it canceled off, that n plus 1, I also have to say I cannot let equal 0. So the important thing is, before this video, I've always shown you, do excluded values first, which will help you because it helps you remember that even when you cancel, you keep those as excluded values. You have to consider them. So here are two excluded values. We cannot let n equal negative 9, and we can't let n equal negative 1, because that would force us to divide by 0. So in these ones, when you get longer problems, you can wait until you factored everything nicely, then look at the original denominators and look to see which pieces are there and set each of those individual pieces equal to 0 so you know what you can't use. So, quick little recap. So, to multiply rational expressions, you first have to factor. Then you cancel any like terms, then you multiply across the top and across the bottom of the fraction. So again, little recap of what you should have gotten out of this video. So thank you so much for joining me. And make sure you have all this written down. Come back to class with some questions and we will do our practice work.